Now let's zoom out for a second. We're going to get the weighted average just like we did before, but using the multiple players next season, since again, we don't care about their current season. We want to see how they perform the following season and then use that to project our current players next season as well. We will use everything we have created to date and combine forces to make sure we get the players next season, adding it all together and getting us one step closer. So if we had our same for loop from before, which was taking the sum of the stat, it was taking the sum of the weight, and it was looping over our ranked DF. Now, this was previously using our sample ranked DF, but in reality, we're going to have the master DF that's sorted, and then we're going to want to just take the 10 rows, skipping the first since that is going to be the current player season compared to the current player season, since you're going to be most similar to yourself, and then taking the iter rows. And here is where we need to add a continue statement in case the row or season ID is 2017-18. Because what's going to happen is if this row season ID equals 2017-18, we can't take the following season since that's the one we're trying to predict. So we're basically going to say, hey, if one of those 10 players happen to be a similar season in the 2017-2018, skip them. And so instead of finding 10, it will probably find 9, or instead of finding 10, it may find 8. But this all balances out since we find the average, which the sum of the stats and the sum of the weights will only be 8. The addition of the 8 players and then divided by 8. So to add to this, we'll get the next season by taking the current row's season ID and adding one like we did before. We can use our find player function to find the player's next season row of stats and save it into a new Pandas object so we can access the columns we need. So again, down here, we have our weight equal to 1 divided by the row's distance. And you'll see now I am accessing things via the row distance and the row season ID, since we're going to be looping over our master data frame. And then what we're saying here is this next season is going to use our season list, where we get our season list index for the row season ID, add 1 to that, and then here's the big payoff. We are going to say our player next season of data is going to come from our find player function, which is going to take the rank DF as the input, the row.player ID as the player ID, and then this next season variable we just added. So here, if we had the current player's season was 2001, 2002, then their next season is going to be 2002, 2003. It will be the same player ID, looking in the same data frame, but then getting their next season stats using our find player function, and then saving this to a player next season object. We're also going to introduce something new, and that is the getattr method in Pandas. So this is the getattr method. This method is used to access the attribute value of an object and also gives us an option of executing the default value in case of unavailability of the key. So for example, if we had an object, let's say person, that had several attributes, including the name and gender, we can access these attributes usually by writing the object name followed by dot notation. So if we had this object person, we could get the name by calling the person's name or the person's gender and so forth. But what if we don't know the attribute's name at the time that we write the program? For example, we have an attribute's name stored in a variable called attribute name. And this is where we could say this is equal to the gender for the person. Then instead of writing person.gender and saving that to gender, we could write the gender equals get attribute person attribute name. So let's get the attribute of the stat column we are currently looping over and access that for the row so we can multiply it by the weight. Then we will want to save it into the SumStat variable so we can get the total. What we're going to do here is pick up where we left off. And now we're going to say the sum of the stat is going to be equal to the get attribute method of the player next season, and then the column is the attribute that we care about. And from here, we're going to multiply by the weight. And as we did before, let's add the weight, because in the end, we need to divide the sum of the stat total by the sum of the weight to get the averages. So here we would add in the sum of the weight plus equals the weight. And then one last thing to keep in mind, there's a chance the player's next season does not exist. So if the player next season equals none, then similarly, we're going to want to continue. Great. And then again, like before, we want to add all of this back into our data frame. So the current player ID, the projected stats, the projected season ID is going to be equal to that season list where we find the season list index of the current player season, and then we're finding his next season as the projected season ID. And like before, the projected stats, we're taking that projected column plus the column name, and that's equal to our sum of our stat divided by the sum of our weight, which resets each time to 0 in that for loop as we loop over the for column in the stats. Cool. So there you have it. We can now get the weighted averages for the 10 most similar players following season to project the season stats for our current player. But this is just for one current player. We want to predict the stats for all the players in a fantasy draft. So let's turn this bad boy into a player comparison function.